The Indian Association of Structural Engineers, also known as IAStructE, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAStructE is registered under the Societies Registration Act 21 of 1860. IAStructE is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAStructE has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IAStructE is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAStructE has collaboration with various international professional like-minded associations and institutions. IAStructe's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAStructE endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAStructE is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAStructe's activities are widely appreciated and known for quality technical contents. IAStructE is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IAStructe's publications are becoming popular with time. IAStructE has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAStructE started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAStructE is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAStructE has its student chapters in several leading engineering institutions as well. Membership of IAStructE is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAStructE is available on its website www.iastructe.co.in.
सर टंडन साहब आपका म्यूट में है। यस सर।
Okay. So, good afternoon, everybody, and welcome to this webinar on challenges in design and construction of underground cut and cover. And your speaker is Mr. Chiranjeev Sarkar. So, before we start, I will just try to find out the what is the timeline of all this. Uh, Vikas, do you know about the timeline? When is it supposed to finish?
Sir, I think the presentation is about
Hello?
1 hour.
नहीं आपका आवाज नहीं आ रहा है हाँ जी
Hello. The presentation is of
वन
about
आवर
one
इज द
hour. Yeah, sir.
presentation
Yeah, sir. Followed by
और टोटल
1 hour presentation and followed by question
हाँ
answer session
presentation is 1 hour and we can have another half an hour of
for question answer.
are you talking about total 1 hour? Hello, Mr. Vikas.
Sir, 1.5 to 1:30. 1 hour 30
I
minutes.
think he's disappeared.
Hello.
No, sir, he is saying the
The
presentation
total.
is around
Okay.
1 hour. Presentation is around 1 hour, and after that it is a half an hour is a require apna is a for question and answer, so that if any participant has question they
Yeah.
can
ठीक है
discuss it. So it is in total 1.5 hours, sir.
yeah okay fine. So now everybody knows, including all the way we are going. Uh, so it gives me great pleasure in introducing Mr. Charanjeev Sarkar, who is the principal engineer at GeoConsult India, and with whom our organization has had a long collaboration in several projects, be it metro particularly and other types of underground constructions. There are cut and cover, there are TBMs, there are NATM, there are all kinds of underground constructions we have done. And the specialization that GeoConsult has is in geotechnical engineering, apart from, of course, whatever structures are involved in all these type of constructions. I think that is what has made this organization a force to reckon with in our country. And Mr. Chiranjeev Sarkar is the principal engineer, and I will just read out for you his a short CV so that people know a little more about him. He is postgraduate experience and planning for railway, road, and bridge projects, contributing
Tandon sir, there is some weak internet connection from your side. I think can you now your
in eight
voice is
major
not audible properly.
He leads major tunnel
Tandon sir.
Wi-Fi connection. Let me change it.
Yeah,
Oh,
yeah, yes, sir.
uh, ये तो एक ही कर रहे हैं यार। हाँ, एक एक
Wait for a minute. I think we are just working on it.
Okay. Hello,
Yeah.
can you hear me?
Yes. It is much better.
Yes, sir. Audible.
Much better.
Yes.
Okay, we have changed the internet connection.
Thank you, sir.
So hopefully this will be better.
Yes.
But if there is any problem, please stop me. So I was talking about Mr. Rajiv, Mr. Chiranjeev Sarkar, and I mentioned something about what all he is doing as far as metro systems are concerned. That is in about 8 different cities across India, and he is also connected with Mumbai Ahmedabad High Speed Rail Package C2, Jaipur Metro JP03, and NFR Tunnel T12. So he has been connected with a number of organizations apart from metros in India. He has presented and published more than 12 papers at national and international forums and received several accolades, such as being a finalist for the Young Tunneler of the Year at the International ITA Awards 2021 and winner of the Industry Expert National Award 2020 and Research Excellence Award 2020. He is actively engaged in professional bodies and he serves on ICI, that is the Indian Concrete Institute, IGS, Indian Geotechnical Society, ISET, which is the Indian Society of Earthquake Technology, and the Governing Council of TAI, which is the Tunneling Association of India, and is currently pursuing his PhD in tunnel design at Jadavpur University. So I have his biodata is quite long, but I have made it quite short, and I hope that I have covered all the important attributes of Mr. Chiranjeev Sarkar. So now may I hand over the podium to Mr. Sarkar to begin his um, presentation.
Uh, okay. Thank you, sir. Am I audible, sir?
Yes,
Yeah. Yes.
you're audible.
Okay. And is my screen is visible, sir?
Yes.
Yes.
Okay. Okay. Good afternoon, everyone. It's first of all, I would like to thank IAStructE for arranging online webinar and invite me as a speaker. So sharing panel with Mahesh Tandon sir, it's itself privilege and honor for me. For better internet connectivity, what I will do now, I'm going to off my camera and I would request all of you to mute yourself also so that we can have a better presentation, and definitely you can raise your question and raise your hands if you have any question in between, or
If you have
moderator
any, I
can.
think just interrupting Chiranjeev. If
Yes,
participant has any question and answer, they can drop in a
uh,
Q&A box so that
correct, sir.
I think do you want to be disturbed in between or you want to tackle those question and answer at the end of the session? Choice is
Sir,
I
sir, yeah, sir, please.
of time and everything else.
Yeah, better would
Sir,
be that if the participant put a question answer in a question answer box
Yes.
and
Then,
after the
mhm.
presentation, you can take it, those
yeah,
questions.
Yeah,
I think that will
yes,
be much
sir.
better.
Yeah.
Okay.
Okay,
Thank you,
please.
Mr. Patiwar.
And
Yeah.
mhm. Okay, sir. Then, with your permission, I'm starting the presentation. So, again, good afternoon, everyone. Today, I'm going to share my experience in the design of tunnel and underground structure for metro projects. So, topic of my today's presentation is challenges in design and construction of underground cut and cover box station of Chennai Metro Phase 2 Corridor 3. Uh, So about myself, I'm Chiranjeev Sarkar, Principal Engineer from Geo Council India. I'm not going to elaborate myself again because already Master and Sir interaction have good interaction. Just I want to mention one point that I am a regular member of IRC Hill Road and Tunnel Committee, H10, for publication of IRC 52, SP 48, and IRC SP 91 code, and also member of a working group 9, that is Seismic Epoch of International Tunnel and Underground Space Association ITA working group 9. These are the contents of my today's presentation. It's include general overview, location, geology of the Chennai Metro Phase 2 Corridor 3, various type of challenging features of Chennai Metro Phase 2 Corridor 3. In my today's presentation, I will discuss three major challenges as a three case studies. That is the first challenges, features, or first case study is on the design and construction of underground station at mixed ground condition. Second case study is the design and construction of intersecting interchange of station. It is also lying on the mixed ground condition. And the third case study will be on the design of an underground station supporting a flyover and ramp. So current slide is showing the Chennai Metro Phase 2 Corridor 3 alignment in the purple color you can see. It's include 29 underground station with associate 20-kilometer tunnel. Entire Corridor 3 package has been subdivided into 5 contract packages, UG 1, 2, 3, 4, and 5. So, yeah, my previous company, ACOM, was the detailed design consultant for the entire Phase 2 Corridor 3, and I'm quite lucky that I was the technical structure lead for 22 underground station out of 29 underground station. So, regarding the geology of the Chennai city, entire city is classified into 3 region-based geology. That is sandy areas found around along the river bank and the coastal area, and then the clay mostly covering the entire city, and hard rock area found in the some central and the south part of the city. So Chennai Metro Phase 2 Corridor 3 contains various type of challenging features like you can see first underground station at mixed ground condition, means half of the city station seated in the soil and half of the station seated in the rock. That is called as a mixed ground condition. Then intersecting interchange of station laying also mixed ground condition. It is a intersection of 2 line, that is the corridor 3 and the corridor 4 line, and this station is also situated in a mixed ground condition. And the third one is the flyover. One flyover is above the entire length of the station. So and the fourth one is underground station, having the cross passage, having the cross over station, having the 2-level parking. So out of these challenging features, today I will discuss this first 3, that is the UG station at mixed ground condition, intersecting interchange station at mixed ground condition, and the flyover running along the station. These 3 challenging features we will discuss during our session. So now I will move to the first one, case study 1 on the design and construction of the UG station and mixed ground condition. These are some major salient features for case study 1 presentation. Design and construction of Thiruvanmiyur underground station of Chennai Metro Phase 2 Corridor 3 has been chosen here as a project specific case study. So Thiruvanmiyur UG station is belong to the contract package UG 5. You can see this is the purple line I have shared, and this is the Phase 2 Corridor 3 alignment, and this is the Thiruvanmiyur station. So this Thiruvanmiyur station has been chosen here as a project specific case study. Current slide also showing the borehole location marked into the station box. And based on that, this geotechnical long profile has been plotted. Further, station box has been superimposed into the geotechnical long profile. You can see from the this is the rock line diagram. You can see this is the rock line diagram, and this is the tunnel line. This is the tunnel line. So you can see that half of the station situated in the soil. This is the above the rockland diagram. This is the soil, and the below the rockland diagram. This is the rock, and half of the station situated in the rock. So as a part of the station description, current slide showing the station geometry of Thiruvanmiyar UG metro station. Length of the station is 152 meter, and height is 16.5 meter, and width of the station at middle is 20.25 meter, and 20.35 meter, and the end the shaft area, launching shaft, retriever shaft, it is 24.05 meter. As I already told in the previous slide that half of the station situated in the soil and half of the station situated in the rock. So due to the difficulty in the digging in the hard strata, that is in the rock strata, as well as due to the self-standing nature of the rock, dual is proposed here. You can see the section dual is proposed to be terminated above the base level. This is the roof slab, this is intermediate slab. In the metro we generally called as a concourse slab, and this is the bottom slab, base slab. So generally we having dual below the base level, having some embedment of 4 and 5 meter below the base level. But here you can see due to the presence of the rock level, we can't having very difficulty in grabbing and the tension of the diaphragm wall. That's why dual is proposed to be terminated above base level with the help of shear pin and toe pin. I will later slide I will discuss in detail about the what is the shear pin and toe pin. And of course during the excavation stage, toe pin provide the stability to the diaphragm wall. And of course after the excavation and the casting of base slab, a 1.2 meter thick stitch wall has been provided as a connection between the D wall and the base slab. This is called the stitch wall. So shear pin and toe pin has been provided just below the D wall, and after the casting of base slab, and then a stitch wall has been further provided as a connection, and this connection provide a box behavior of the structure actually. Now due to the varying rock layer along the station alignment, three cases has been adopted as a part of the models of project specific case study. The first one is the case one. If we found that the rock level, there are three probable cases may arrive. The first one is the if rock layer found at around base level, then generally we have to, what we have to do, we have to terminate diaphragm wall around 3 meter below the base level. This is typical our station generally. Typical arrangement generally we do with the D wall. Then in the case of in case 2A, if rock layer is more than 3 meter below this the concourse level, if rock layer found more than 3 meter below the concourse level, then that is called the case 2A. And if rock layer found within the 3 meter below the concourse slab. So we don't know the actually what are the starting level of the rock along the station line. So there three probable case may arrive. If rock layer found below the base level, then there should not be an issue because we will have a good embedment in the diaphragm wall. But these three probable cases, course condition may arise. The first one is the if rock layer found at the level of the base level, that is the case one. In the case 2, if rock level found within the 3 meter below the concourse level, and rock level found more than 3 meter below the concourse level. So our toe pin, basically this shear pin, the toe pin is required for both case 2A and 2B. This is you can see D wall, there is a one steel member is inserted into the diaphragm wall. That is called actually toe pin or shear pin. It's provide basically adequate embedment to the diaphragm wall during the excavation below its level. In the next slide, I will show in detail more about the shear pin. Current slide showing a diaphragm wall with a toe pin arrangement system. You can see toe pin is embedded into the rock layer uh, to provide adequate embedment into the diaphragm wall. Due to the presence of the hard rock strata in the diaphragm wall, trenching and grabbing stack up, and as I already mentioned that station is in mixed ground condition. So uh, due to the presence of sudden presence of hard rock layer, the dual tension and grabbing may stack up, and definitely project can suffer badly. So that time structural steel member like this shear pin can be used as a innovative and economical engineering solution. There is many other engineering solutions, but this shear pin is can be used as a innovative and economic engineering solution. You can see so here use of structural steel member as an innovative and economic engineering solution for underground structure. You can see here this is the starting level of the rock line, and this is the steel member. 3-meter embedment has been provided and 2-meter inserted in the diaphragm wall. In the later slide, I will show a little more detail about the shear pin. Here you can see it's a 5-meter D-wall panel. 3 shear pin has been put it into the 5-meter D-wall panel. This is a small view of this small portion view. This small portion view I have share here. It's a elevational view actually. 3 shear pin you can see. Here you can see that the toe pin this toe pin is embedded into the rock layer. This is the rock layer. This portion is rock layer. So toe pin is embedded into the rock layer to provide the adequate embedment to the diaphragm wall. So presence of hard rock layer, diaphragm wall. This D wall in rock scheme plan elevation, and here you can see this is the plan. This is the elevation, and this is the cross section. A 250-meter dia pipe actually basically 250-meter dia pipe through the diaphragm wall here you can see, and a steel prefabricated I-shaped member has been embedded into the rock layer through drill hole. So generally what happened you can see here it is the drilling in the rock, and this is the D-wall part. And so this is the shear pin part here. Basically it's a dia of 250-meter pipe, and for 250 and a prefabricated plate steel member actually are inserted into the rock, and the gap between this gap between the tube and the member is filled with grade 40 non-shrink grouted material, and further some fissure grouting is also applied into the rock for excellent bonding. Now I will come to the what are the advantages. Advantages is that there is no requirement of the separate time and activity for temporary earth thickening structure arrangement, as the top down sequence of diaphragm with the D wall has been chosen here. So then there is a no requirement of additional space for earth thickening structure, because we are choosing the top down method and with diaphragm wall. And definitely there is a major savings of quantity of temporary earth thickening structure, and fastest construction with less manpower involvement in this top-down method with dual, and no requirement of separate traffic decking arrangement, because with the top-down construction sequence it can be managed easily. After casting of roof slab, traffic can be diverted above the roof slab. This is the major advantage in the top-down sequence actually. In the after casting of roof slab, you can divert the traffic above the roof slab. And of course, there is in present case, since we are not casting full height of diaphragm wall, so of course there is a reduction in the D wall embedment also. So these are the advantages, and definitely there is some limitation. So major limitation is it's required more skill, manpower, and equipments. So that is the limitation here. As a part of the construction stage analysis, entire construction stage analysis is done in the Plaxis software. Toe pin is assigned into the model as a spring stiffness equivalent to its member property. Here you can see toe pin is further assigned as a equivalent to spring stiffness, and here you can see initial stage, dual installation stage, then excavation stage, then excavation in the intern stage, then backfilling stage, then the service concept. So different stages of sequence has been done. So that has been shown here. So as a part of the service stage analysis, entire service stage analysis is done in the StatPro software for both 2A and 2B case. You can see 2A and 2B as I mentioned earlier also. And in 2A, 2B case, there will be the stitch wall. So stitch wall here model as a enlarged section. So definitely the envelope of all the cases like construction services has been considered for detailed RC design of D wall and the stitch wall. So this is the service analysis. Now, as a part of the stability analysis, entire station box has been checked against toe stability in Plaxis 2D software. Factor of safety for toe stability has been found within a permissible limit. You can see from the stability curve shown here. And ground stability also been ensured by checking ground surface settlement with respect to its limiting value. You can see these are the ground stability check has been done, and definitely horizontal deflection of diaphragm wall has also been checked for different stages of the excavation. Here you can see, and it is also found within a permissible limit. Now, current slide is showing the bending moment and the bending moment diagram. This is a shear force diagram. Bending moment and the shear force diagram for D wall, and the RC design of the D wall is done based on this bending moment and shear force diagram. This is nothing but say envelope of all the cases like service stage and construction stage analysis. Steel structural design check for toe pin has been done as per IS 800 2007 code. For shear pin steel design check has been done. Now I will just quickly discuss the conclusion part of the project specific case study one. First, the unconventional and innovative technical solution have many times saved the project from its long standstill. As I mentioned that due to the presence of hard rock layer, our tenching and the grabbing of D wall was stuck up. So that time, unconventional and innovative technical solution has been adopted. Then, of course, as I mentioned, that the structural design of the Thiruvanmiyur station, which fall in the mixed ground condition of Chennai Metro Phase 2 Corridor 3, has been referred here. So, due to difficulty in the excavating hard rock strata, the arrangement of the shallow diaphragm wall means it's terminated above the base level with a shear pin means. Toe pin embedded into the rock strata with a stitch wall has been adopted as I shown in previous slides. So this arrangement basically reduce the requirement of any kind of temporary earthing structure like soldier pile, second pile, whatever. And of course, therefore, it helps saving time, manpower, and of course, material cost for separate temporary earthing structure support, because we have chosen here a D wall with toe pin system, not a bottom up sequence. And definitely entire sequence of construction stage has been analyzed in finite element based numerical model for checking of structural design stability and ground deformation, etc. Definitely during the design and construction, there was one topmost priority has been given, especially on the stability of the structure and the stability of the adjacent structure also. So these are the few references which has been referred during the detailed design and the publishing the paper. Of course, as a presenter, I acknowledge the support received from the entire team involved in the Chennai Metro Phase 2 Corridor 3. Just for information, this paper was published in IGC 2021, and it got award of best paper award at that IGC 2021. So this case study was published already. Now I just quickly move to the case study 2. Sir, am I audible properly?
Yeah,
Is there
yes,
any
yes. No issue.
is there any difficulty in my presentation or audio?
No. Please go ahead, Chiranjeev.
Okay, sir. So now I will move to the second challenges features, that is the design and construction of intersecting interchange of the station lying on mixed ground condition. So these are some salient features of case study presentation 2. Design and construction of Thirumaila station of Chennai Metro Phase 2 Corridor 3 has been chosen here as a project specific case study 2. Thirumaila interchange station of Corridor 4, that is you can see here in the it's an interchange station. This is the interchange station. This is the yellow line. That is the Corridor 4, and this is the Corridor 3. So this is coming the interchange station Thirumaila, you can see here. So Thirumala interchange station of corridor 4 in yellow line, and corridor 3 in the purple line of Chennai Metro Phase 2 corridor 3. You can see here, this is the interchange station. Entire Thirumala station, interchange station is subdivided into the mainly the two part, which is the first is the island station along the corridor 4. This is the you can see this is the station along the corridor 4. You can see this is the station. It is intersecting intersection. This is one station is along the corridor 4, and this is another station is along the corridor 3. So it is intersecting each other. So there are two part of the component of the main entire station. It's a two component. One is the island station along the corridor 4, that is along the corridor 4. This is the island part of the station, and there is a narrow width. You can see the width of this station is a little narrow width station along the corridor 3. This is the corridor 3. This is the corridor 3, and this is the corridor 4 alignment. So entire station is subdivided into two parts. That is island part of the station is along the corridor 3, and the narrow width part of the station is along the corridor 3. Actually, since the station having the narrow width, therefore what happened, there is a stuck of the upline and upline track and the downline track. There is a stacking of upline and downline. So since the station not having the adequate width for two lines, so what is proposed, that there will be stacking of upline and stacking of downline, and the corridor 4 station will be is proposed as a island between this upline and downline. In the later slide I will show in more detail as a 3D image. Here you can see, so the width of the station is quite narrow because of the land and other issues. There is no adequate land available, and there's some site constraint also. So the station was proposed as a narrow width. Therefore, it happened. It's a stacking of upline and downline, not two line in parallel like here. It's a stacking of upline and downline, and the island part of the tunnel is going as a in between of upline and downline. So here you can see three dimensional view of interstation box of 3 mile station along with the intersecting area. This is the intersecting area. Now cross section of corridor 3 station. In the left hand side you can see cross section of corridor 3 and the interchange area. Hello, sorry. Cross section of corridor 3. Here you can see on the left hand side, and in the right hand side you can see the cross section of the intersection area. So you can see here that the corridor 4 track is placed in the island between the upline and downline. This is the in the plan you can see the cross section. In the this cross section is from the stacking part of the station. You can see this is the upline, this is the downline, and it is the island part of the station. And now I have cut a cross section from this intersection area. In this intersection area you can find that this tunnel of the intersection area, means island part of the tunnel, is passing in between the upline and the downline, this in between the stacking of upline and downline. So I think image I think the view is clear to all. And you can see as I told earlier that the geological condition of the Chennai city is mostly clay. Sand area is found along the river bank and coastal area, and hard rock found in most some central and the south part of the city. So for 3 mile station, surface stratum at the site mostly consists of cohesionless soil, and you can see here loose sand, medium sand, dense sand, and this all these are the cohesionless soil, and which is further followed by weather rock. Current slide showing that the depth-wise geotechnical parameter which has been used for detailed design of the this 3 mile station actually. Further, station box has been superimposed into the geotechnical long profile. You can see here this is the station box of the island part of the station, that is the corridor 4 part of the station. And this is the geotechnical profile long sectional with superimposed station box for the stack part of the station. You can see. So here also you can see that the half of the station situated in the rock and half of the station situated in the soil. This is the tunnel line diagram. So due to the varying rock layer along the station alignment, two cases has been adopted as a part of the model specific case study. That is the case 1 and case 2. Now what is case 1? Case 1 basically rock at or below the island undercup slab level. If I found rock at island undercup slab level, then that will be, and then in that case diaphragm wall with a typical embedment of 3 meter for if we found a grade 4 rock, and if we found the rock like grade 5, then there will be embedment requirement of 5 meter. So typical case 1 is basically applicable here. You can see this is the island part of the station is relatively having the lesser depth because it's in island part, and stacking part of the station having relatively having the more higher depth, and there is the more area in the rock zone. So most part of the island part of the station, basically, island part of the station, that is the corridor 4 part of the station, having case 1 condition, that is the rock mostly found below the undercup level and having a embedment of 3 meter for grade 4 and above beta rock, and 5 meter embedment for grade 5 case rock. Now, in the case of case 2, if rock layer found below the island undercup level, then and definitely above the lower undercup slab. So in that case, what will be happen here? You can see this will be in the case of higher depth part. This part here you can see that the here we need a toe pin which would be embedded into the rock strata to provide the adequate embedment to diaphragm wall. That is would be required for the case 2. So case 2 will be applicable for the entire stack 3 part of the station because it is having the relatively higher depth. So now current slide showing typical case 1 cross section. Here you can see there is a no shear pin and toe pin because here having 3 meter or 5 meter embedment of the diaphragm wall below the bottom slab. Here you can see. So this is a typical case 1 cross section, and 3D sectional view also you can see. This is for the 3 layer island part of the station, which is parallel to the corridor 4. Now you can see the current slide showing that the cross section with case 2 condition. Here you can see that the toe pin shear pin has been provided, and of course there is some rock bolting and all those things has been provided. And here you can see the D wall is not in the previous slide. You can see the D wall having a embedment below the bottom slab, but here you can see D wall is terminated above the bottom slab, and definitely there some toe pin is required. So this portion is required here in the previous slide. In the typical case 1, you can see only roof slab, commercial slab, undercup, upper undercup slab, and this is the island undercup slab. There only the 4 level of the slab. And in the present case, you can see there are the total 5 level of the slab: roof, commercial, upper undercup, island undercup, and the lower undercup. Because this is the intersection area. This is the stacking of upline, stacking of downline, and this is the island part of the station. So this part of the station, narrow with stacking part of the station, having relatively higher depth and relatively more embedment into the rock area, and it's required this dual toe pin systems here. So current slide showing different stages of construction sequence of narrow with of a typical top-down construction sequence for both case A and case 2 conditions with enhanced model in the Plaxis 2D software. Current slide you can see the different construction sequence for island part of the station. Island part mean again the station part parallel to the corridor 4, which is having the typical case 1 condition. Typical case 1 condition means the D wall having the adequate embedment. So this is the different stages of construction sequence is modeled in the finite element software. This is the initial stage, D wall installation, in intense excavation stage, and the backfilling stage. So so this is the construction sequence for the island part of the station with case 1 condition, means D wall having embedment. Now you can see current slide showing the different construction sequence of narrow with stack part of the station with the case 2 condition. Case 2 condition mean there would be dual toe pin and these things. So toe pin is assigned into the model as a spring stiffness equivalent to its member property. So these are the different stages of the construction sequence of narrow with the stack part of the station with case 2 condition. As a part of the service stage analysis, the entire service stage analysis is done in the step software, that is case 1 for island part of the station, which is along the corridor 4, and case 2, that is the stack part of the station, which is basically parallel to the corridor 3. And definitely stitch wall is modeled as an enlarged section, and envelope of the all these cases has been considered into the RC design of D wall and the stitch wall. All different level of the slab has been checked by developing. You can see developing the 3-dimensional plate model with permanent opening, which is subject to the full service condition load under ultimate and the serviceability limited conditions. So you can see here the 3-dimensional stat model also with having the opening at the top of the station box. So these are the analysis part, construction stage and service analysis, and as a result, stability analysis also performed. Stability of the entire structure has been checked against the toe stability and Plaxis 2D software for both island part of the stack part of the station, and you can see the left top is the island part of the station analysis, and the right bottom is the stack part of the station stability analysis check has been done, and both the cases has been found within a permissible limit. And definitely ground stability also, ground analysis also check for entire excavation and construction has been performed in Plaxis 2D software for both stack part and the island part of the station. Here you can see ground settlement curve in the Plaxis output envelope for the island part of the station. In the left top and the right bottom, you can see the ground settlement output envelope for stack part of the station. And also, of course, factor of safety for toe stability also been found within a permissible for also the ground settlement, and also it has been checked with respect to its limiting value, and it is found within a permissible limit. As an outcome of the different series of the model analysis, both for the island part and the stack part of the station, deformation, then bending moment behavior of the diaphragm has been studied in detail. So current slide showing that the deflection of the diaphragm wall that has been checked with respect to its different stage of excavation and construction for both in the left hand side the island part of the station and right hand side the stack part of the station. So this is the horizontal deflection of the diaphragm wall that has been checked for different stages of excavation, and it has been found within a permissible limit. And of course, bending moment, the current slide showing the bending moment diagram for diaphragm wall that has been plotted. This is for stack part of the station, and the left in the right hand side. In the left hand side, the iron part of the stations. This is the bending moment diagram for both cases. For different stages of excavation, backfill, and service condition. And of course, the RC design of the diaphragm wall is done based on this bending moment diagram envelope from entire service stage and construction stage analysis. And again, the design of toe pin, that is shear pin, has been checked with respect to its as per criteria of IS 800. Now I will just quickly discuss about the conclusion part of the project specific case study 2. Due to site constraint and the land issue, corridor 3 part of the 3-mile station is adopted as a narrow width stack station. As I already mentioned that we can't get the adequate width of the station, which is generally 20 meter or 24 meter. Here there was no adequate width was available for the entire length of the station. That's why it has been planned as a narrow width stack station. So therefore, what happened? Corridor 3 station has been proposed as a narrow width stack station. Therefore, the corridor 4 part of the station is proposed as an island station between the stacking of upline of downline with an interchange connection area actually. So as a part of economical approach of the design and construction, Thirumale underground station has been proposed with a top-down method to get the advantage of the diaphragm wall as well as the faster construction, less manpower and equipments, and definitely due to the encounter of the hard rock layer, shallow depth diaphragm wall with the toe pin in between the rock strata system has been adopted here, and definitely further stitch wall has been provided as a connection between the D wall and the base slab. So this is the especially that system was required in the case 2 case, means the station having the higher depth, that is the stacking narrow depth station. And definitely major challenges were faced due to the unsymmetrical and the irregular shape of the station box, since it is the intersecting and interchange, and of course the different level at at the one side the 4 level, one side the fifth level, so different level at interchange connection area, and definitely uncertainty of the rock profile which occurs, complex behavior of the station geometry under varying loading condition. So this was the challenging features, and definitely structural stability and the safety of the adjacent structure was ensured by checking its limiting value in every stage of the analysis and the design. So these are the references which has been used during the design of Thirumale station. Presenter also acknowledge the support received from entire the team involved in the Chennai Metro Phase 2 Corridor 3, DDC client, checker, contractor, everyone. And this paper also, just for information, this paper also published in 9th Civil Engineering Conference in Asian region, that is called Olympiad of the Civil Engineering, Session 9, and that was in the published in 2022, this paper. Now, I just quickly, due to the shortage of time, I think I have few minutes left. Due to the shortage of time, I will just quickly move to the third case study, that is the design of a underground station supporting the entire flyover and ramp actually. To provide multi-dimensional transportation system for a busy road crossing at Radhakrishna Salai junction. This is the junction of the Chennai city. A highway flyover is planned above the underground metro corridor. So design and construction of the Radhakrishna Salai junction station also referred here as a project specific case study 3. The station comprises 3 level of the slab supported by 2 diaphragm wall. This is a typical station, typical top-down station. 3 level slab mean roof slab, intermediate concourse slab, and the bottom slab, and is supported by the diaphragm wall in the as a external wall, forming the station part as a internal framing. And both main station part and the launching or retrieval shaft has been proposed to be built by the top-down sequence. And in addition, there is a flyover you can see here that is running along the length of the station, which is to be supported on the roof slab. Here you can see the flyover means roof slab will be behave like a foundation of the flyover actually. Here you can see this is the long sectional view of the Radhakrishna Sala junction station with the flyover running along the station length. This is the flyover pier system, and this is the precast girder are there. So here flyover pier is supported on the roof slab, which is basically rested in on a beam, cross beam system. The later slide I will discuss more detail. So you can see flyover also, and there is a some part of the is a ramp part also is there. So this is a 3D isometric view of the Radhakrishna Salai station running along the length of the station. So this is the long sectional view here. This is a 3D view, and this is a 3D long sectional view. You can see roof slab, intermediate slab, concourse slab. This is the ticketing area is there, and then this is the base slab, and this is the platform area also. So, and flyover you can see this is supported on the roof slab with the help of the cross beam. This beam also supporting in the diaphragm wall. So this is the 3D cross sectional view. One is through the pier location, and another was at the end of the station location, at the ramp location basically. So as a part of the design of the flyover supporting system, the structural design is considered here as a critical forces from, of course, different construction analysis. Actually, entire design has been done in two part. That is the critical forces from the construction analysis has been obtained from the soil structure interaction with the using of finite element software. And then the loading of the pier, there is a mostly typical span of 20 meter long flyover span supported pier is supported on the roof slab with the help of a cross beam of 3 meter by 3 meter wide and 2.4 meter depth. Means this is the 3 meter wide and 2.4 meter depth, which turn into the support into the 1 meter thick diaphragm wall. And there is a one junction pier is there that is having a span of 35 meter and 20 meter. So it is also supporting on a 2 meter by 2 meter column which turn into the supported into the base level. So these are the below table shows the all possible load has been considered in the designing the support system for both 20 meter span and 35 meter long flyover. So this is the summary of the design forces for 20 meter flyover span load in the longitudinal and transverse direction, vertical rotation, everything is there for most two typical OATS condition cases. And this is the load summary for 35 meter plus 20 meter flyover span. Two type of span is the 20 meter and 35 meters flyover span. And you can see that the load has been assigned to the both 2D and 3D model. Here you can see that is in the 2D frame model with a flyover load also apparent, and these are the bending moment diagrams. Just one identical diagram has been just shown here. So based on this bending moment diagram and of course the envelope from the construction stage and service analysis, the design of structural member has been done. And just quickly conclusion part, just we can say the underground construction are definitely as a conclusion of the all three case studies, we can sum it up like that the underground construction are gaining popularity day by day by playing a key role in the improving many more urban space congestion problem, as you know. And so the every capital city in our country is nowadays planning for a metro, and of course underground construction is gaining popularity because of its virtue of because of this space congestion problem. So underground construction is gaining popularity, that's why. And definitely to provide multi-dimensional transportation system in a busy road crossing Radhakrishna Salai junction Chennai city, definitely, as I mentioned, that a flyover, entire flyover is proposed above the underground. Means first underground station will be constructed, then flyover will be constructed above the station. So present case study describe this design concept, optimization opportunity, challenges of this underground station supporting the flyover and the ramp. And station comprises three level of the slab supported on two diaphragm on the both sides. And diaphragm wall is considered as the external wall of the station with slab forming a part of the internal framing. An entire underground station construction is planned with the top-down sequence, and flyover and the rampart has been planned to cast later once the civil work of the underground station would be completed. And definitely one key word was there, that the structural stability of the entire structure and the safety of the adjacent structure is to be ensured in every stage of the design and construction, and that has been ensured by checking its limiting value in the every stage of the analysis and the design. So these are the few site pictures actually for Chennai Metro Phase 2 Corridor 3. This is the picture during the installation of the diaphragm wall actually. this is the slab. This is the at the concourse level actually. So thank you again. I think I have completed within time. I have been given, and then if you have any query, you can further contact with me through LinkedIn or by drop my personal mail address also chiranjeevsarkar.civil@gmail.com. Now I think this session is open for question answer. So
Thank
yeah,
you, Chiranjeev. Tandon sir, are yeah, yeah,
Yes.
yes, sir.
You want to say something?
Yeah.
Please go ahead.
No, you go ahead, please, sir.
Well, okay. So this was a wonderful presentation by Mr. Sarkar. It shows you the problems in the urban situation. The metros and etc. They are basically meant for transportation within the city. It's not from city
Mhm.
to city. It's within the
Yes,
city.
sir.
And the cities, as you know, they are already becoming crowded. They've got already so many obstructions. There are flyovers, there are tunnels, there are buildings which are already constructed. So you have to, when you first problem is to make the alignment, whether it is underground or overhead, what
Mhm.
alignment to follow without uh, disturbing too much the existing situation. Of course, one thing
Mhm.
that Mr. Sarkar forgot to mention, these underground stations, they are so huge that they invariably encounter a lot of utilities. And
Yes, sir.
handling the utilities is
Mhm.
one of the biggest issues. That means that you can't remove the utilities.
Yes, sir.
Sometimes you can divert them and put them back again, but that is not always possible. For example, if
Yes,
you
sir.
have a pipeline of some 2 meter
Mhm.
diameter, you can't
Mhm.
you can't
Mhm.
divert it. It remains there only.
Uh, mhm.
So, and of course, the other interesting issues which come out of Mr. Sarkar's presentation, you see the stacking. By stacking, it means that instead of having the up and lying down at the same level, you are putting one on top of the other. So this is called
Mhm.
stacking. So
Yes, sir.
this stacking will occupy less space, and like he said, in many of the cases, there was not enough space. So you have to have this stacking done so that in plan you don't occupy too much of space. Normally, the alignment we try to go along the roads. That
Yes,
is
sir.
the at least you will encounter less buildings, etc.,
Mhm.
which would otherwise be difficult. But it is everything is not just a straight line. Some of the tunnels they have to pass
Mhm.
through underneath the buildings, and then you have to
Yes,
check
sir.
those buildings. Some
Mhm.
buildings have pile foundations. You have to make
Yes,
sure
sir.
you don't get into problems
Sir,
with the piles.
even in the Lucknow Metro, we have tunnel just beside the Lucknow Vidhan Sabha, and we don't
Yes,
have some information that what are the actually level of the basement level. Our just tunnel is just to increase the Lucknow Vidhan Sabha Foundation. You can remember that LKC06 project. Then
yes,
we shift the alignment and those things.
correct. So other things, what one found was this Plaxis is a very sophisticated and good software, and everybody uses it at some time or the other. But it is the 2D which we use normally. I don't know about the 3D. We have never used
Hmm.
it, and I don't know whether Mr. Sarkar has used it. Perhaps he can
No, sir.
throw some
Actually,
light.
general, we have Plaxis, we have Midas, but particular that project, people use Plaxis. So nowadays, the where there are the very other software is available like Plaxis, like Midas, and some project people are using RS2 for the basically tunnel design, not for the station box design. And we mostly use STAD also for substability analysis.
Yeah, I
So
mean, those
substability.
are the structural softwares, but
Mm.
basically Plaxis concentrates on underground
Yes, sir.
geotechnical kind of.
Geotechnical software.
Yes, sir. Yes, sir.
So,
FEM, yes.
so it's an FEM, but
Mm.
I think that most of the people, at least I have not met yet somebody who confidently says that I have done 3D Plaxis and everything is fine. I think you're likely to make more mistakes than. So unless you are a specialist who has got years of
Mm.
experience of using this particular software, I think 2D is what you should do. And of
So we
course, like
mostly use 2D. 3D basically people used for the academic and the research purpose, and it's
yes,
generally it took lot of time for analysis and this 3D modeling, sir. Mm.
that's right.
So 2D is quite easier actually, sir, for time
As a
saving
matter of
and.
fact, a
Mm.
simpler software is the Wallop,
Mm.
which gives you
Yes,
the
sir.
at least the diaphragm wall, bending
Mm.
moments, and all that quite easily, and very
Yes, sir.
easy to use. And
Yeah.
it has a limited amount of
Mm.
inputs to be given
Inputs.
instead of this Plaxis. So anyway,
Yes.
all these are
Mm.
tools in an engineer's toolbox, and he has to use the right tool for the right project. And if the, so, you that is something which is again, I would say, has come out of Mr. Sarkar's presentation. So you can see that this has now become a fashion. The NHAI and the local authorities, they want the flyover to go on the middle of the road at a higher level. So
Yes, sir.
if you are making a making your station and you are following that, so on the station part you have
Mm.
got a ready-made foundation. So
Yes,
you
sir.
just you
Yeah.
support the flyover on top of
Mm.
the station, and of
Yes,
course you
sir.
have to make sure that you can transfer the load satisfactorily. But this
Mm.
is again something which is forced upon us because we are working in an urban environment. It is not a free
Yes.
field thing where you can do whatever you like. It is very,
Yes,
very
sir.
constricted. So that is another thing that has come out of Mr. Sarkar's presentation. But now I think let's take on the questions that have been put by many people. Uh, Mr. Patiwar, you will
Yeah,
take it on.
I will read some questions, answer,
Yeah,
to
and
Mm.
next up in the box. I think there are some
let
questions
Mr.
in the
Sarkar
chat
answer.
box. The
Mm.
chat, no, only questions I will place it so that appropriately he can maybe reply. It was a good presentation, I must say. And of course, moderation is nicely, I think, not much but no better than Tandon Saab himself. So there are
Mm.
some questions in a question box. See, I will read one by one. There is a one
Mm.
question from Anand Kumar. After the installation of shear pin, how is the excavation done up to the base slab level?
Mhm.
So I think
Okay.
I don't know, madam.
Yeah.
See, yeah, I think you might have
Okay.
done the first drill the hole and then maybe place
Yes.
the pin, but you can explain it properly.
Yeah, yeah. Actually, sir, it's a good question. First question that exactly where we are going to put the shear pin because of the we found a good rock condition, and due to the presence of the rock, we can go for excavation, means grabbing or trenching, means because of the presence of the rock layer. So since you have the rock and you have already inserted shear pin, so in the rock area, you can go with the open cut excavations with some little maybe 85-degree or means a little slope, sometimes vertical cut also, because if you have a very grade 2 rock or grade means a good kind of rocks, so you can go for a open cut excavation, and of course depending on the rock criteria and the site condition, you can put some rock bolting, shortcutting kind those things arrangement. In my presentation also I have shown some rock bolting and shortcutting in those things. So if you have found that no, you have very good kind of rock, like even grade 1, grade 2, so nothing is required. Vertical cut is sufficient, but it's depend on your geological condition at that time, that the site. So depending upon that, your excavation. So after excavation and casting of base slab, then there will be stitch wall connection that will connect base slab with D wall, and then it will form a complete box. So then there would not be any issue in the. Okay, sir. I
Yeah,
think I
thank you.
have.
I think there is another question in the same line. I think you have already replied. So Mr. Kirod is asking that how excavation oblique drilling for installation of I section done in rock below D wall. So I think already you have replied that answer
Yeah,
also.
yeah.
There is another question by Dr. Sushil Dhawan. A few challenges faced during planning and construction, management of drainage and excavate soil and rock, mechanism of structural health monitoring during design and construction, prevention of corrosion in structure steel members, the parameter considered in design and construction for climate change for making structure durable and resilient. These are the some, you know, observation he has raised for your
Yes,
presentation.
sir.
So would you like to apna go
So
one by
yeah.
one or see?
I can give a general answer. Actually, in my presentation, I discuss about one concept that if you found that rock in your diaphragm wall in during the trenching or gapping, then there would be a solution of putting shear pin or toe pin below the diaphragm wall. There are the many other solution, and definitely here you have mentioned that nowadays people are definitely you can use the corrosionless steel and drainage system. So each and everything are the depending on the site specific condition actually. So whether it is your site in which city, what is your ground condition, whether any what are exactly what are the water table is there any exposure condition, what are the exposure condition. So all these criteria, and definitely consultant and proof checker and of course clients should look into the matter that it's not one's calls actually. I believe that if one project is not only for the client, is a project for is for actually it's by the people, with the people, for the people. It means it's for our country's projects for every Indians actually. So once if so ultimate outcome will be once all we work together, means client, contractor, DDC and proof checker. So for sake of the project, so people has to work out the what are the exactly site demand, what are the site conditions, and based on that, yes, corrosionless steel you can use. But here its durability is not major concern, because shear pin and toe pin embedment is for certain time period, because we are after D wall, after casting a base slab, there will be a definitely a 1.2 meter thick stitch wall that will be connecting our diaphragm wall and the base slab. So of course corrosion because we don't know the exact time framing, but definitely it can be proposed. But everything depend on the cost, time, and all those things, budget. Sometimes is also tender specification, something is mentioned. So each and everything.
Yeah.
I think this
I think
not a direct technical question, is
no, but I
quite
think
such.
Tandon sir, if would like to add something on the durability, I will take his opinion also.
Yeah, I think that I only have to say one thing. We have been discussing about this shear pin. Firstly, this shear pin that we are talking about, it is in the diameter of the circle that he showed is 250 millimeter, and it is going through the diaphragm wall. That means that you first have to uh, create a pipe. I mean, leave the pipe before you concrete the diaphragm wall, and so that you don't have to drill through so many 20 meters of concrete to reach there. You leave the pipe. and it is 250 millimeter diameter. The thickness of the diaphragm wall may be 800, even 1 meter sometimes. So it's very easy to leave the pipe, and then you have to drill only whatever is remaining part there, and then you have to grout it to make sure that it is uh, sort of gets becomes a part of the substrata, which is rock. And this shear pin obviously has to have not only the capacity to take vertical loads but horizontal loads, because you got a tremendous amount of earth pressure,
Sure.
and part of it will be transferred there also. There are other people who don't like this, not don't like, but they think of another alternative. That means that at the bottom of the shear wall, where you are putting a pin, they put a rock anchor
Oh.
at that
Yes, sir.
level so that it is
Yes, sir.
stabilized. And afterwards, there is no problem because you got this is only during construction. During service, you got so many of these slabs which are going to come and support your diaphragm wall. So this is actually a temporary stage requirement that you what we are talking about, not really a service stage. Service stage, you got enough
So
enough
horizontal
support,
types,
Support
etc.
system.
horizontal support. Yeah.
Yeah.
Okay, thank you. Let me not take too much time.
No, it's okay. It is always pleasure to listen to you. And I think what challenges were encountered during the construction of the flyover plus station in case study 3? This is a question from Abhinav. I think it is a general question. If you want to answer, I think Chiranjeev
Okay.
can answer.
Yeah. As a challenging part, of course, flyover loading, because you have the two separate analysis, one of the above ground structure analysis and the underground structure analysis. To avoid this, yeah, definitely it could be a good research, because of the there will be debate also that the behavior of my above ground structure, seismic behavior, especially in the case of the lateral load behavior also. I think Tandon sir, I want to listen this question reply from Tandon sir also.
Tandon,
But
sir.
definitely, whatever my understanding, because we did 3-4 different type of analysis, but what finally we decide to simplify the design, that we took separate analysis for flyover part, and then we applied this load into the underground structure. Otherwise, it will be very difficult to create an integrated model, that will be, because underground we will have a seismic loading, that will be racking behavior, and the lateral load, and the above ground structure there will be some ground shaking, those things. So that will be so we definitely we have done that analysis also parallelly, but as a part of the simplest design, we took, and definitely we have chosen some conservative approach also, based on that. And the challenges was that, definitely as a part of the challenges, the flyover foundation actually, that is, flyover is supporting on the roof slab, and what we did, we put cross beam, 3 meter wide and 2.4 meter depth
I
cross
think your
beam.
voice is.
Am I audible, sir, properly?
Yes, yes.
For a moment it
Yeah.
had gone, but if you can just speak a
Okay.
little closer to the microphone.
I'm using actually Bluetooth headphones, sir. Okay. Then the cross beam actually, which is as a conceal beam with the roof slab, that has been provided as a part of the support, because in this flyover is using the station as a foundation of the flyover actually.
Sir, what is
So
Tandon sir? This actually my question. Matlab, see, what is your opinion about the transferring the load from the superstructure pier and then
yes.
again to beam and then transferring to the diaphragm wall? What is your any your views?
Oh, you see, vertical loads are very easy to transfer. I mean, we try to do it in the buildings all the time. There are even transfer girders in the where it is displaced. So we know how to handle vertical loads quite well. The problem in this case is, it is like an inverted pendulum. That means that you have the load is in the superstructure of the metro, which is high above, and it is the connection is with some column or mostly column, of course, in the underground construction. So it's basically it should be a continuation of that instead of trying to have another transfer of loads. It should be vertically. It should be one column that goes and supports both the roof of the station as well as it continues and then it supports the metro at the top. That should be the configuration. But now people are talking about not only that, they are talking about two levels above. That
Yeah.
means that your metro is is at the top. Then you have a huge 34-meter wide carriageway, and all that is supported on top of this the underground
structure.
station. So it's like you can have many things, but vertical loads, I think, are not an issue. We know how to take care of them. It is the horizontal loads because you got a different type of situation here. You, in an earthquake, your earth is shaking.
Yes.
That is where, and providing you forces on the whatever is underground. But if you just go up, it is not. It is really the what do you call it? The mass inertia
Yeah.
of the things at the top, which
Yes.
are shaking the whole thing.
Correct.
So how to take care of this is
Through the beam.
of course, it's a through. Oh, that thing is like an inverted pendulum, which is not the best way to do it. But then what to do? Perhaps this is an Indian invention, but we don't have space. We got narrow roads. We have to. Those roads must be there even after you construct. And then NHAI wants, also, oh, you are making something, so please make a flyover there. And so it's quite a problematic thing. But generally, what we try to do is you put R equal to 1 for
Correct.
at least the structure which is till you connect to the
Diaphragm.
to the underground construction. That whatever is above can be designed as an R equal to 1 kind of a situation for earthquake. And then, of course, it is challenging to see how to do the connection. But if you just continue the same column, it is much simpler. And then because the design of the underground box, which Mr. Sarkar didn't get into, it has got a different type of design.
Yes.
It's I think he did mention one word I remember that it's a sort of a what word did you use, Mr. Sarkar? The uh, for the earthquake forces underground,
Racking.
that whole thing has to be uh, sort of designed differently. I mean, it is not just earth pressure. It is the whatever
Linking
your box is
analysis.
will become a parallelogram. You have to
Yes.
put forces in a different fashion. So
Yes, sir.
maybe you should deliver another lecture on the design of the underground construction because I think then only people will understand
Thank you,
and
sir.
how it has become so complicated that you have an overground structure, you got an underground structure, the two are designed differently and yet they are connected, but they must
Together.
behave together.
We have to.
So
Yes, sir.
I mean, ideal thing is to have one model for the whole thing, but then really it is wise because you should be
Hmm.
sure what you are doing.
Hmm.
And if your model becomes so long, big, uh, you may make more mistakes than whatever is
Hmm.
It is extreme engineering, I
approximate
can say.
the way
Hmm.
we are doing. You do the top separately, you do the bottom separately, and connect the two.
Very
So I
true.
don't know what your opinion is, Mr. Sarkar. You've done so much research. Do you think
Actually,
that we
sir,
should
we
design
get
it separately, or should we have?
actually, sir, what I want to mention that we get advantage of this cross beam, sir. One mammoth 2.3 meter by 2.4 meter wide cross beam, which was actually the flyover pier is supporting on the beam and beam also connected
Yeah.
through the diaphragm wall. So that advantage we actually got in. Of course, there is a longitudinal connectivity with the slab also, definitely. But that advantage we actually took in this cross beam.
Sir, we'll take this problem separately because I think there are so many questions are there by the
Okay.
Please.
audience. So we'll take it because I think this is a big topic which require a very extensive discussion.
Yes.
Mm, how much clear distance between tunnel has been taken where island tunnel cross stack station tunnel? This is a question from Mrutyunjay Pandey.
Mm, what do you mean? Clear distance means there is it's a
Between two
actually
tunnel, I think he's asking.
okay. Actually, uh, in our case, the entire 3 mile station is a one complete station, and the station having two component. One is the a part of the station which is parallel to the corridor 4, that is called the island part of the station, and the part of the station which is the parallel to the corridor 3, that is the narrow with the stack of the station, and it is basically intersecting interchange. It's not parallel, it's like a perpendicular, and definitely the upline, and I have shown in my PPT also that there is a one since it is narrow width, so there is a upline and downline, and the tunnel is passing inter island tunnel is passing through the intersecting the upline and the downline, and particular that intersecting zone having one more additional floor. So of course, so there is no such kind of things here. It's a floor, it's a different kind of slab level actually.
Okay, I think Mrutyunjay must be happy to know this answer. I think there are so many other questions regarding the station and that connection. I am skipping that. I think I will pass over to you and then you can reply those in the detail because there are many questions on that. And there are
Mhm.
some questions in a chat box also. So I will, 1 second, I will just go through that. If any relevant question is there other than which we haven't tackled. Uh, there is a one. What was the depth of rock level and soil level below ground level? This is a one simple question is by
Mhm.
Saurav Kar.
Okay, actually, I have shown two presentation. This question belongs to case study 1 or 2, I don't know. But
Correct.
yes, in our project, we got rock level around, soil is still 8 meter below the ground level. And around it's varied because of the it may be varies from 6 to 8, some are 6 to 9, so 6 meter to, and then below that we found so above soil we have different kind of sand layer, loose, medium, and you can remember in my presentation I have shown one geotechnical property table also depth wise. So it is already available, and below that we found the weather rock actually grade 3, somewhere grade 2, and
Okay, and see, I think at cross-section point of view, when and how the shear pin, I think already that answer has been replied. There is another question from Kar. Sorokar, D wall is cast in situ or precast? I think it is
It's
precast.
cast in situ.
It is
So
cast,
D wall
sorry, it is cast in situ.
cast in
Yeah,
situ.
it is
D
cast
wall
in
is
situ.
cast in situ.
Then how drilling through pipe into rock is done in order to but prefabricated steel I section. This also has been replied. Um, what is the ground stability? How is it different from toe stability check? I don't know. Let's see if you have understood this question.
You want to mention there are two stability. One is the ground surface settlement. Another is the toe stability. Means we have checked ground surface settlement also with this limiting value. After the analysis, that what will be our surrounding ground surface settlement due to the excavation. Because since I am excavating 150 meter by 24-meter area, so what will be the surround grounds surface settlement? So that also we have checked, and definitely we have checked the toe stability of the entire structure. Based on that, the embedment of the diaphragm and all those things has been finalized.
So that is through the Plexix software you have done and then find out.
Yes, sir.
So there's one question from Abhineet Kodayal. How arrangement of reinforcement with I pile is done for proper connection? If it is in situ, top-down construction. That is his question, I think.
Sir, could you please repeat? I pile?
How arrangement of reinforcement with I pile is done for proper connection? I don't think where the
Okay.
actually you have
Sir,
taken it.
actually we have used diaphragmal because in the diaphragmal is basically nothing but a rectangular shape pile. Means it's size of 1 meter by 5 meter, and diaphragmal provide a very good positioning of the coupler. You don't means instead in compared to the circular pile or any kind of other shape of the pile, because in the circular pile like say for a secant pile kind of things, it will be very difficult for the keeping coupler for the different slab level. We have three level of the slab: roof level, intermediate, concourse level, and the base level. And generally in the diaphragm wall, we keep coupler for connection of with the slab. So since diaphragm wall is the rectangular shape, and it's generally hold coupler in its position, although there is some coupler tolerance we found during after installation also, but still it is there is a chance of less. But in compared to the circular and other shape of the pile, diaphragm wall is having good provision for this coupler holding.
Thank you. Thank you. I think there is another question. Kanan is asking, what is the advantage of shear pin when the D wall is already embedded into 2 meter below the station excavation level?
Station excavation, you mean to say? Because see, if you
I think
found the rock level,
he understand that see your D wall is not going deeper than the whatever the bottom cutoff level.
if generally if we found the rock level at around the base level, then definitely dual can go another 1 or 2 meter beyond that level. So in such case you don't need any shear pin system. But in case you found rock level above the your bottom slab level, means if you found rock level just below your intermediate slab, or just 3-4 meter below your intermediate slab, then what will be happen? Because you have to reach your excavation level till the bottom of your till the soffit of your bottom slab base level, no? So then for such a time your D wall will not get adequate embedment. So that's why we provide the shear pin, which is basically embedded into the rock, and also it is inserted in the diaphragm wall. So its shear pin itself provide the adequate embedment during the excavation and the casting of base slab. And once the casting of base slab is done, then you will we provide connection stitch wall.
I think you have to support the shear either by the wall embedment or by the, if it is not possible, that is why you have used the shear pin to transfer.
So that's why it is called shear pin.
It is
not
correct.
vertical pin.
Yes. So I think someone is asking, Mrityunjay is asking, is it not good to provide strut in place of shear pin, and strut can be reused after base slab casting, and avoiding of excavation in hard rock can save cost time for shear pin? Also, what is the here required?
Okay, as I mentioned that yes, Sir also mentioned that is for the major concern is the shear, because vertical load we don't have any issue because of the since D wall is resting on the rock, so it will automatically transfer vertical load. So, but our concern is the stability. So yes, instead of putting shear pin, you can use ground anchor. Means you can anchor the diaphragm wall, as Dennis also mentioned. You can anchor the diaphragm wall toe in the rock, and you can put the start oiler. But among all this method, shear pin method is quite economical and easier. You can see you have to do nothing, just drill 250 meter into the rock, maybe for depth of 3 meter, 2 meter, and just put one pipe and one prefabricated eye member, and just fill that void between the pipe and eye member through the non-sink grout. Nothing. But in case of your start, you have to put start oiler system, and then there in the side there would be a issue, because there should be your machinery movement and equipments, and your because we have to cast base slab now. If we put the start, then there may be some space issue for the machinery and the man movement and all those things, because you have to cast maybe 1 meter or 1.2 meter thick diaphragm wall, and you have to, before the casting of diaphragm, you have to excavate, you have to fabricate your reinforcement, all those things. So that may be there might be difficulty if you have start oiler arrangement actually. And of course, CRP method is the cheaper among all these method actually.
I think
But
construction
yes,
easy is one of the best of now actually
yes,
say is
yes, yes.
easy here. I think
But
Tandon
yes,
sir
those are the
yeah.
also, yeah.
Tandon sir, if you would like to say something on this, I think I will be happy.
On this business of the
Sir, strut,
shear pin,
shear pin are the strut. See, strut is also a can be answer. Maybe are the shear pin also can be answer. But see, what is the preference to be given, and what is the what is the advantage and disadvantage? That is the question.
Sir, actually, question is
I
that
think
in what
one
in
thing
compare.
is made temporary stages.
Mhm.
We are not doing this for the service stage, because in service stage you have got a lot of other things which are going to support the diaphragm wall. But in the temporary stages, you don't have that. And your diaphragm wall, if you just excavate in between, inside the station, then you have a free cantilever height of some 20 meters, which can never be stable. And it can never be made safe. 20-meter tall, just anchored at the bottom. So you have to find ways and means of doing this. And like Mr. Patiwar said, there are many ways. One is that you got two sides of the station, which are, let us say, 20 odd meters apart. One diaphragm wall, another diaphragm wall. And this is the station in between. Now, if you put a horizontal strut which connect the two walls, you are balancing the earth pressure from both sides. So that is, of course, you can do that as one of the things instead of uh, you know doing many.
solution.
This is one of the options that you have.
So
You can use uh, options where both the things are done. For example, you can use, instead of a shear pin, which I personally don't prefer, we put a rock anchor. That means that from the where your wall, where it has met the rock, you can't go any further, because making a diaphragm wall go into the rock is highly costly kind of a proposition. So we normally stop it at the top, or if it is soft rock, we go a little bit inside, and at that level you start putting rock anchors which go into rock. So your base is stabilized. It doesn't go anywhere. And if it is sitting on top of the rock, the vertical loads are already transferred. So all these options are available to you, and you use one or more of these in order to be able to get over this temporary state. Because service stage, it looks very pretty. You have got a box, you got
Sure.
you got a number of slabs, so
Yeah.
it is stable. But how to get there is the main challenge.
True. There are many ways, but ultimately they have to decide based on the which method they feel the best for the construction as well as the as per the strata, geotechnical strata, and all those considerations.
Correct. I think this decision has to be made with the person who is going to construct it, the designer of the structure, and of course the geotechnical engineer. The
Correct.
main person is the geotechnical engineer, but
Very true.
you have to involve the structural engineer and you have to involve the constructor, because he should be able to do it. If you suddenly say you make rock anchors and the fellow says, no, no, I don't have the equipment and I don't want to do it, then you must, as engineers, come up with another solution. But this decision
Sir,
should be taken jointly.
thank you. Thank you, sir, for your opinion. Another question is there. How do you consider the vibration induced by train in nearby buildings in your numerical model? Do you consider that? Or if you consider, how you consider that? I think that question is open to Chiranjeev.
So, concern of the vibration during the train movement, correct?
Yeah, that is his question.
Okay.
Are we
Uh,
considering such numerical analysis where, see, suppose if the train is passing through the tunnel, then any such vibration analysis is done to see whether the effect of the that
Sir, for underground structure, because the vibration and what are the situation we generally face, that is during the construction stage. Once you complete your construction is done, because since your station is in within the soil, na, because you have after casting of station, you have 3-4 meter backfill over the your top slab also. So enter the station. It is inside the soil, and then station box having 3 level of the slab, means two floor is there, and in the bottommost floor there is a movement of actually train. So there should not be, we could not found any difficulty, and it's not actually not at all required nowadays also, since we have a nowadays blastlet track and all those things are there. So for this train movement, there is no such kind of vibration which need some alarming situation kind things for train movement, because of the, since it's an underground structure. I think
yeah.
I want to listen from Tandon sir also because
No, what you said is right, at least for 90% of the time. But if you see how many complaints DMRC has received, that ever since
so that is for the
you
construction
started this,
stage, sir. So that is for
huh?
the during the, sir, that is during the construction stage. Once
No,
we
no.
complete.
Even after completion, they say that
Okay.
every time your train goes into it, the whole house, which is located just next to the track or next to the tunnel, the whole house shakes. So, what is the guarantee that it's not going to fall on us?
Actually, it depends what is the geotechnical, strata, and then what are the waves which is
Yeah.
after passing the tunnel, how it is propagating to the side of the, tunnel, or what are the structure is there, and how it is affecting the adjacent structure. So that may not be everywhere the same, that okay, it is not happening in a one place, so it will not happen to the other place. It is not necessary. It depends on the how the waves are propagating through those geotechnical strata. What is the location of the structure, whether it is transferring any vibration to the foundation layers, and then it is of course affecting those things.
Sir, also during the construction stage, we have closely instrumentation and monitoring system is also there, because and also we have building condition survey and instrumentation monitoring, we can identify then there is some vibration also, and we check the vibration limit also, because the in few sites we have some little deal and blast method also in the rock area. So there in such kind of project in like Mumbai also, some there is some little drill blast method is also open. But there is some little vibration issue also.
I'm aware of the bridges or the pedestrian bridges when it is required to be check the frequency and then see whether those structures are sensitive to the vibration or not. But see, I'm not aware of the tunnel, so let us. I think yeah, yes, sir.
Mr. Patiwar,
Yes,
I
sir.
want to say, you mentioned all these points, but one point you've not mentioned. What is the structure like? Because most of the places, like we are making something near Chandni Chowk, the buildings there are 100 years old.
Yeah, true,
And some of the buildings, it is unbelievable, but they have no foundation.
true.
And over the years, they made one story already existed. These are shops. There another shop has come on top. So you got two-storied building without any foundation, and it is 100 years old. No drawing, nothing. Forget about drawing. Then no information is available. And those type of things are so risky. So what we have to do every time, and I think Mr. Sarkar will bear me out. First, we do a condition survey of the building, so that if there are already existing cracks or things like that, we photograph it, we keep a record of it, so that afterwards, once the train starts moving, they show you cracks. You say that, this crack already existed when even before.
Very true.
I mean, we had the same situation in this Ambassador Hotel. They showed, although all this was done, they showed cracks. They showed first photographs that look at all these cracks which have come because of your station being there at Khan Market station. And look at what has happened to our, hotel, which is a five-star hotel. But they did, nobody went to the side. We just saw the cracks. Then one day, one of our engineers said, "Let's go and have a look at these. What is it? Even if we have to put what is that called? Glass,
Yeah,
glass pieces to see whether it is expanding, contracting." We found that the photograph that they had taken was not of the wall which was adjacent to the construction. They are talking about the wall which is on the other side, parallel to it, but another 20, 30 meters away. So they are showing cracks in that, which were never, nobody ever mapped that whole building. We just did whatever was necessary. So there are all kinds of things. Some are real, some are imaginary.
and some are maybe because
So
of the
you
old
have to be
structure
careful.
foundations are not properly
These
engineered
old
that.
structures are very, very difficult. It
So,
is all non-engineered. There is no question, and they are not in concrete. They are in some kind of brickwork, and it is not only in Delhi. If you go to Bombay, for example, and you go to
yeah,
places like Kalba Devi, or you go
yes,
to Dadar, you
yes,
go to
BT,
many of those parts which are really old Bombay,
yes, yes,
their buildings are 100 years old.
correct, very true.
So it's a problem.
I think I will take the last question of a session now, because it is a time to end, and so that I will ask Dr. Tandon Sahab to summarize the session after that. See, the last question is, what is the best way to learn Plaxis software? Is someone asking? I think maybe Apna, you can inform that there are, see what are those agencies are there and how someone can be trained from that. And another is in a continuation of the same, that how underground under alignment survey are done using which technology and tools. So that is his question, which I am taking the last question. And there are many other questions which I will ask IAStructE to send it to you, and then actually those answer can be individually sent to the the people who have asked those questions. So
Should I reply, sir?
yeah, yes.
uh, Reply to this question. First, request IAStructE to arrange one workshop on the Plaxis, so that based on your request, this association will arrange some training program for people like you. And
This is very
apart
good
from these
idea.
things,
I will say I will immediately ask
yeah.
Vikas to actually let us. You are giving very good ideas, so we'll continue with that.
And also request IAStructE to arrange some training also on the tunnel and underground structure. Okay, and there are not only Plaxis, there are some other softwares also. You can have a look on that part also, like STAT, like Midas, and
I
like
think already we
RS2.
are doing it. See, Midas,
Yes, sir.
Office are, apna, see different, even see
So,
Nemes check is there. See,
mm,
those sessions we are keeping, but if you feel that
yes.
Kipna, you another some softwares are there, we'll be very
Mm,
keen to have their programs. Generally, such
mm,
programs we like to have a presentation by the practicing engineers and
mm.
physical presentation, then the apna web presentation, and it
Yes.
can be covered in a various metro cities. So that is the idea,
Yes.
but we can think about it. Plexus
Yes,
as well.
yes. So IAStructE having office in 4 cities. So preliminary, it can be planned in the four
Sure.
cities of the India, and then otherwise, second answer is you can directly connect to these Plaxis people. They are available in the LinkedIn. And apart from these things, very soon, maybe on 20th September, my university, Jadavpur University, is going to arrange one hand-on session on the Plaxis, on the design of the tunnel and underground structure. So if people around the Kolkata, it's a free event. I will maybe by tomorrow I will share this post. You can register and you can join that session. It's a free of cost, but it will be physical event. You have to come to Kolkata and Jadavpur. So to attend that, it's a free of cost event. 1 day session, hand-on session to learn the Plaxis software, especially for in the field of the underground structure and the tunnel and slope stability. So that session will be there. There will be one case study presentation from my side also again. That I will be there also is my college, and then there are some other way also. You can connect
I
through.
think you can forward that information to Vikas, and I think he will forward to the apna participant. Whoever suppose they are nearby to the Kolkata and they want to attend, they will be able to, they will attend it. And I would request Tandon Saab to summarize the in a few words this presentation so that we can uh, close this session.
Okay.
Today's session.
Thank you, Mr. Patiwar. All I have to say is that first, a big thank you to Mr. Charanjeev Sarkar for a wonderful presentation, which show you the actual position in the urban environment and what all precise answers to the questions which were raised. So that was a wonderful thing, and that has uh, made this webinar worthwhile. But in no way the contribution of Mr. Patiwar is less, because he has so ably handled this question and answer session, and he has not only compressed the number of questions, he has left out where he thought that we are going to get stuck. We'll only be discussing one question.
No, sir, it's
So
a
that,
time limit
It is
also.
a it is a small
yes,
it is a learning slowly, sir, and I think see with a PDT committee, apna it is we have to do that part of the job also.
that's right. No, that was done wonderfully. And thank you so much. And thank you to Mr. Vikas for more or less a uh, seamless kind of a
Arrangement
webinar.
and all those things.
I don't think there were many things except that
Yes.
my
True.
own thing started a little late because it was we had to change one of the the Wi-Fi connection itself to another one. So that was all I have to say. And I don't know about I think everybody asked, what about the presentation? Vikas?
I think the presentation Chiranjeev Sarkar will share with IAStructE. Once he will share the presentation, we will share with the participants and send it to them.
Yeah, I
Oh,
will
acha.
share the presentation. No issue, sir.
I will
I
request
mean,
it.
if you want, because many people don't share.
Yeah, that is true.
So, what we generally do is that if Mr. Vikas is here, um, he will confirm the same
Yes,
that
sir.
there is a site of IAStructE in YouTube where
Yeah.
this thing, the presentation
recorded.
is already recorded.
Yes.
It is kept there for a certain length of time, and anybody can go and see it. I don't know whether you can download that presentation or not, but you can
No,
see it again.
you can't download, but you can see that presentation.
But so, Mr. Vikas,
Yes, sir. Yes, sir. It is on our YouTube channel, sir.
on
Sir, I
YouTube,
think for me actually already this case study I've already published and it is available. So interested people
okay.
can directly download it from it's open, nothing to
So then
so
I think if you can be kind enough just to send it to Vikas, your
yeah,
presentation, and he will
Mm.
send it to all the participants who were here. He has
Registered
got
there.
all the
Yes.
addresses and everything. So
Correct.
that will be
Mhm.
it's very generous of you to do that, because the last time I was attending one of them, they said that,
I will only remove sir case study 3 because case study 3 there are some values and all those things are available actually, and that paper actually accepted and not published in a printed version, sir. So let it come.
No,
So
fine.
meanwhile I will
Whatever you want to share, you just
yes.
see you
case
can
study 1 and 2 case study 1 and 2
fine,
already published, but 3
fine.
printed version is not yet come actually. It's officially approved.
No
Yeah, and
issue.
if somebody wants to see your case study 3, he should go to
Mm.
YouTube and
Yeah.
see
Yes,
your
sir.
presentation
Mm.
again.
Yes.
That's
Yes,
it.
sir. Entire presentation is available in the YouTube. Mm.
Very true.
So is that correct, Mr.
Yes, sir.
Yes,
Vikas?
Yes, sir.
sir.
Yes, sir.
Yes,
So
sir.
so what is the YouTube? What is that called? URL?
Sir, it is a IAStructE
IAStructE.
YouTube subscription is there. They can go there and then they can
YouTube
watch the
and say
presentation.
what?
IAStructE,
So you go to YouTube, you say Indian Association
I will send the
of
link.
Structural Engineering,
Yes, sir. I will send the link along with the presentation
and
handouts to all
and
the
this will be
participants.
one of the presentations there.
Yes.
Yes.
Is that right?
Yes, sir.
Yes,
True.
yes.
Yes, sir.
Okay.
Thank you, sir. Thank you
Right.
for your
ठीक है.
gracious time and presence, sir. Thank you for your
No,
moderation. Tandon, sir.
always a pleasure to.
And thank you, Chiranjeev.
Mhm. Thank you,
I
sir.
think,
It's my pleasure to share
and
panel with you and Master sir.
you have given an idea for Plexus. We will certainly will have their presentation also very soon. Thank you.
Sir, not only Plaxis, you can have a good workshop in tunnel or underground structure.
We will
Uh,
certainly
So,
will
Mr.
certainly.
Sarkar, before you
mm,
go away,
mm.
I hope that when you give the next webinar in IAStructE, we can call you Dr. Sarkar.
Yeah.
Sir,
Is that right? How
sir,
much time will it take?
sir, my PhD is going on. I don't know. Actually, I could not have much time because of this office and work pressure. Although I have completed my coursework and term paper leading to thesis, but still to journal and those things, I maybe it may be another 2 years times. Maybe I don't know.
So a few months.
No, sir, it may be 2-3 years
Few
because,
months.
yeah, you can say 24 months.
All the best.
Anyway, so wish you all the best.
Wish you all the
Thank
best.
you,
Yeah.
sir.
Thank
Okay.
you. Thank you.
Thank you. Thank you.
everyone. Thank you.
So I think with that,
We are close.
let's close.
Yes, sir.